Hi everyone, thanks for being here. I know the other presentations are very, very nice. So WebKit 2 is not that sexy, so it's nice for you to come here. So today is going to be WebKit 2, looking forward. So the agenda will be just a little introduction. I'll talk quickly about WebKit 1. So WebKit 1 is what you find on Qt today. And of course, I'm going to talk about WebKit 2, exactly what it is. About me, so there was a mistake on the paper. My name is Alexis Menard, I'm not Pierre Rossi. Yes, you heard well, I'm French. Sorry for the accent, that's just the way it is. I'm the Qt WebKit team lead in INDT, so I'm taking care of like 7-person team in INDT. We're working full-time on Qt WebKit. I used to be Oslo troll. I was working for Nokia, Qt development framework. I worked many parts in Qt, QML, graphics view. Last year I did a Qt graphics view in depth talk, so I know my way in Qt. I'm an open source advocate, so I'm fan and I support a lot of open source projects. I think it's very good. I'm now an occasional KD developer. I used to be very active, but since 2006, so I started KD as a student project, and then after I mainly work on Plasma, then I launched the mobile project for Plasma, so it was like running KD on small form factor like phones. Then now it's renamed and called Plasma Active, and people are working full steam on it, so it's very good to see that people took over me. And now I'm just like using it and fixing it when it bothers me, that's all. Working for INDT is very fun because I left Oslo, and by snow, the darkness, and my party friends, and the awesome Norwegian food, which is sausages based, so-called pølse, to Brazil, which is slightly different, which is beach, sun, caipirinhas, and my wife and my daughter. So it was very nice. It was a nice move. It was a smart move. Seriously speaking, let's go back to the presentation. So WebKit 1, Qt WebKit. So what is it? Quickly, I'm not going to go to details. There was a presentation yesterday about it. WebKit is an open source web content engine. Basically, you get HTML5, and it renders it for you, basically. Very simple. It's the most popular mobile engine. You find it on iOS, on Android, on RIM, on Symbian, on many phones. It's driving the open web on the desktop. WebKit community is very active on W3C, as like helping for the standard to shape. And on the desktop, you find it on Safari, on Mac, on Windows, and then Chromium. It's the same. Reconc on KD, or even Conqueror with different K parts. And then there are many Qt apps that are using it. I'm not sure Google Earth is still using it, but they used to do, and then Second Life also is using it. The basic architecture of WebKit, of course I'm not going to go to details again, but like just so that you get a basic idea, so that we can compare to WebKit 2 afterwards. WebKit is like a big piece, and it has like two main pieces inside. It's like you have web core. So web core is everything you need to parse an HTML5, understand it, and render it. It also manages the CSS for you and all this related stuff like SVG and so on. And also you find the so-called HTML5 APIs, like to make the HTML5 less, to follow and make the HTML5 stuff work, basically. And then you got another smaller pieces, which is the JavaScript engine. One sits on the webkit.org repository, which is JavaScript Core. JavaScript Core is the one that is developed mostly by Apple, and it's the one that ships with Safari and iOS, like Safari Mobile, so iOS. And otherwise, you get a bunch of glue codes so that you can hook up another script engine, which is the V8 one, which doesn't sit on webkit.org project. It's another open source project and run by Google, and it's another JavaScript engine, V8. people say that V8 runs faster on some benchmark. I'm not going to go into details, but basically you can hook up a JavaScript engine. The default one is JavaScript core, but you can hook up V8. That's what Chrome is doing. Chrome is not using JavaScript core. Chromium also. And then underneath this building big blue box, we got something called the WebKit ports. And you have to see WebKit as like a huge thing that basically will understand HTML, render it, but doesn't have like low-level functionality. For instance, WebKit will not put pixels on your screen. It's like, it will tell you, okay, I need to draw a rectangle. And then this is when the ports come into action. It's like they will say, okay, I know my port Qt, I know how to render a rectangle on the screen. So you basically plug your ports to the WebKit big box, and you plug your network stack, you plug your rendering stack, you plug everything. And so there are many ports. I just put the main one. So Safari, also called Apple one. This is the one that's running on Mac and Windows. And so the API is mostly based on Cocoa, Objective-C. And there is the Google port or Chrome port, which is the one that you find on Google Chrome or Chromium. And also, since like they are working hard to unify also the Android ports into the same one, I think it's almost done. They removed the Android, like the last pieces of Android ports in WebKit. So I believe that now they fully use the Google port. We don't know, but I believe. There is also our friend from GTK that have a port of WebKit that you find on Epiphany, I think is the name of their browser. Better. So and then the Qt port, which is us, and you have also the EFL port, mostly pushed by Samsung. This is the one that they use on their mobile phone, I guess. Same, we don't know exactly. And then you have also more tiny ports like Windows CE ports and so on that are just more minor. We call major ports the one that are build bots running. Build bots, like that's every single commit is builded and then tested. And like the one that you see here have like bots. It's like Qt has like a bot running 24 hours that check every commit, that check every test and see if there are regressions. WebKit is a very, very high quality project because, of course, if you break something, you're going to break a lot of user web browsers, right? It's like if you break WebKit, you break all iPhones, you break all Safari browsers, all Google Chrome browsers, and all Nokia browsers. So it's like you better find the problems before they arrive on the end user's hand. So there's like, we got like a huge number of layout tests that check website, check use cases, check APIs, check HTML use case, check CSS and so on, check rendering, and major ports have those bots running. So GTK has one, Qt has one, Chrome has multiple, Safari has multiple. Actually, Qt has multiple. So we have like on Windows, Mac, Linux. So yeah, that's just this. This is very basic. I'm not going to go into detail. That's all. This is WebKit 1 today. You find in Qt 4.7 or 4.8 through all those well-known classes, Qt WebView, Qt Graphics WebView, Qt WebPage, Qt WebFrame. I mean, I'm not going to go into details. You go to the documentation of Qt, you'll find it. So now, what is WebKit 2? So why we thought about it? It's looking like we make another version. It's not. WebKit 2 is not the next version of WebKit. The name is slightly confusing, especially that Qt WebKit is called Qt WebKit 2.0 or 2.1 or 2.2. Unfortunately for Qt WebKit, we came up with the name of 2.0 and so on before they announced WebKit 2. So anyway, it's too late. Our releases were named like this, we cannot change, right? So it's like, it's not the next version. It's not. WebKit 2 actually sits on the same repository as WebKit. It's just a separate directory, right? So it's not the next version. So if you go back again to the basic architecture of WebKit today, So this is the purple box is your application running. So using Qt WebView or Qt Graphics WebView, it's one process is your application process. And from your application, you call the API of Qt WebKit. And Qt WebKit API actually talk to WebCore, which I was explaining, contain all the pieces and bits you need to render HTML. And WebCore also deal with the JavaScript engine if you have JavaScript on your web page, right? The API boundary is basically on top of Qt WebKit, right? This is where you call your API, this is where you call Qt WebFrame, this is where you call Qt WebPage, where you call Qt WebView, right? So this is today, one process. It works like this, straightforward. So why WebKit 2? And what it is? So it's a new API layer. It's just an additional API that sits next to WebKit 1. It's not a compatible API, right? It's like, for now, it's not a 1.1 API. What you do with WebKit 1, you cannot yet do with WebKit 2. We're still working on it. WebKit 2 is designed for a split process model. Like, means that you have multiple processes. It's a different API for the original WebKit one, just because it's a split process model. Doesn't mean that you can have the exact same API. It will not be the case. And as I said, it sits on the same repository. So you don't see it as a new version. It's just another additional API. Gives more choice to the user, basically. Why WebKit 2? So the main goals of WebKit 2 is to make the UI more responsive. What we don't want is letting your application event loop deal with, fetching the HTML from the network, getting all the signals when the bytes arrive, and then parsing the HTML, rendering it, constructing all the objects, evaluating JavaScript, and so on. This makes your event loop, your application event loop busy. And we actually want to free it from that so that it's always free for managing user interaction. Read, first use case, scrolling. You basically want a smooth scrolling all the time, right? But if, for instance, you are trying to load like a huge image or rendering a huge image, then your event loop is going to be super busy and your app super busy and the CPU super busy dealing with that image, and then the scrolling is going to be slow. And of course, it's like on desktop, it doesn't show that much, but like on mobile phone like this, yeah, that's a huge issue. If you have multiple processes, it improves the stability, because if the web process, like the separate process where you deal with the web crashes, then it doesn't bring the UI with it. You can still restart the process, right? So today, if something happened bad in Qt WebKit, then it crashes, your application goes with it. There's nothing you can do. So let's say plugins like Flash, which are not very high quality plugins, then if they crashes, then the entire Qt WebKit goes down and your application crashes, right? Which is very bad. So Apple, for instance, on the 5.0 Safari, they put the plugin in separate process, right? So that if they crash, then just the plugin crash, right? We didn't do that in WebKit. And actually after this, like Apple thought about like, yeah, well, let's actually make the entire web rendering into a separate process rather than just the plugin. And so today, for instance, if you could use Qt WebKit and then with WebKit 2, then if it crashes, then it doesn't bring the UI with it, which is very, very good. It improves also a bit the security, because if you write an exploit for the web browser you're using based on Qt WebKit or based on any WebKit port, then you will only access to the web process context, right? It's a separate process. So in theory, like for instance on macOS Lion, you can sandbox the web process, like sandbox this separate process, and then you can say, okay, well, this process will only have access to what the sandbox provide, which means that if you write any exploit with it, like it was gonna limitate the damage you could do because it's running in a sandbox, right? So this only for now, I'm aware it's only existing in macOS Lion because they implemented the sandboxing at the kernel level, so you can actually create processes that are sandboxed. Linux doesn't have those features, as well as Windows, but maybe it will come, so we can actually do it. So here's the basic architecture of WebKit 2 today. So as you can see, there are two processes. There is one that we call web process. This is the one that will take care of rendering, parsing, fetching the HTML, and so on, making the website look something. And there's the UI process, which is the one your application is running on. Then you're going to have an API that you deal with it, and then seamlessly translucent, like it's going to be translucent for you. It will manage the process to create the process for you, to render and communicate with it. And actually, afterwards, you can see it on your application, right? So the API boundary is still on the UI process. On your application, you deal with this new API. And then on the back, there will be a communication between the two processes to first run it, then start fetching the. So if you say, I want to go to google.com, then the UI process will going to send a message to the web process. We're then going to start fetching google.com or start resolving the URL and then getting the HTML code for it. And the actual old web core and JavaScript engine and so on sit on this other process, right? This is the one that will render, that will fetch, that will parse, that will resolve the style, that will do everything in time. So, and then you got a communication between both. I have another explanation afterwards. So the main difference is two processes, right? One where your application sits, the UI process, and the other that is taking care of rendering the web content, or parsing it, fetching it, and so on. But for you, the API boundary is still the same. You don't have to care about the IPC. You don't have to care about the other process. You don't even know that it exists. For you, it's totally translucent, transparent in the API. For the curious, Chromium also have some kind of like multiple, like every single tab of the Chromium or Google Chrome runs into a separate process, right? And for them, it's different. They don't use WebKit 2, or at least for now, they don't. I'm not sure they will ever, but perhaps. They have something they call host process, which is where the application is, like Google Chrome, right? And then the application is responsible of creating the processes, right? So every single tab is responsible for creating the process that will actually render the page. And then they have an API which is called, like the application has a render process, and then they just load the API inside, like the WebKit API inside. So the API boundary is not on the UI process, it's actually on the render process, so some kind of web process, right? So as you can see, it's very different. WebKit 2, that's transparent for the application. On Chromium, they manage themselves the thread. So Google Chrome manage themselves the processes. So it's just a different approach. They actually came up with the approach before WebKit 2. So that's the main difference between Chromium or Google Chrome and WebKit 2. So there are two key subsystems that support the process division in WebKit 2. There is something they call core IPC. So it's an abstraction for general message passing between processes, right? It's so that the processes can communicate together. See it like a bit of a very, very simplified version of dbus, basically, on Linux. They made their own because, for instance, Apple came up with WebKit 2 project, right? So it's like, it's not Qt, the Qt team that came up with it, it's Apple, right? So Apple has this tendency of rewriting everything. So it's like, in theory, they could have used another IPC system, right? But like they wrote their own. It's very simple. And then there is, of course, what I'm talking here is very oversimplified, but so that for you it's an introduction, right? I'm not going to the core details, basically, but it's like there is also a drawing area, which is an abstraction for cross-process drawing. So it's like, so that the web process can wander into a shared places that the UI process can read to actually show it on the screen, right? So it's like some kind of shared memory that you can one render, and when they finish, then the other read to show it on the UI process, right? So show it on your application. There are multiple drawing strategies. Of course, the most simple one is a shared memory bitmap, right? You just write it when it's finished, and you just show it. Yeah. I'm not gonna talk about more complicated stuff like accelerated compositing when you accelerate animation and so on, but like this is the most basic architecture, right? I'm drawing into this shared place, and then I show it on the other process when I'm done. So I made a very, very simple example on how this happened. So for instance, in your application, if you ask, okay, could you please load google.com, then it's going to talk to the Qt WebKit 2 layer that will then send a message to the IPC bus that will say, okay, I'd like to load this URL. Then the IPC will then forward it to the web process. The web process will get the message and say, I need to load, and we'll start fetching resolving the URL, then getting the HTML file, and then start rendering. And then the rendering stuff will basically render into this drawing area. It's same, it's very simplified, right? But so you get an idea. And then when it's finished, then it will send back a message to say, oh, I'm finished loading. Then it goes through the IPC. The IPC gets to the WebKit layer on the UI process, and then you finally get the signal on your application, right? Everything is asynchronous, right? Of course, loading a URL is by default asynchronous, right? But like every API that will be with WebKit 2 is asynchronous, of course, because we have to send it to the IPC, and then we have to wait the answer of the web process, right? And then when it's done rendering, then the UI process knows that it can read from the drawing area, and then it will start painting it, right? And in that case, Qt is going to do the painting for you, right? So Qt Painter and so on, right? So Qt WebKit 2 requirements are Qt 5 with SceneGraph. Why Qt 5? Because since it's a huge rewrite, I mean, we cannot just port QWebView to this. It's just a rewrite of the API. We said, well, you know, as like, there will be no Qt 4X release, you know, what's the point trying to develop for it? Let's just go to Qt 5, since we're going to break everything anyway. It's like the API needs to be changed. It's a total new API, asynchronous, and so on. And also the fact that there was SceneGraph, which is very good, because we wanted to use like on mobile phones, for instance, we use like this like tile backing store, you know, when you have tiles so that the scrolling is faster on mobile phone. And then SceneGraph will match really nicely for us. So we can have tiles on the SceneGraph and so on. And so that was one good something that was pushing us to move to Qt 5. And also, of course, that OpenGL is mandatory. Because SceneGraph, right? So it's like, it can be software emulated or hardware, but like we use OpenGL because OpenGL is very nice for us for everything that is related to, you know, CSS animation and, well, you know, stuff like WebGL. We need OpenGL, so it's like, it's easier for us, you know, to have one supported code path, which is the OpenGL one, that we know that's going to perform very well because it matches really good. The problem we have today with Qt WebKit 1 API is like these millions of combinations you have with accelerated compositing. If you use a graphics view, if you use a QWidget, or if you use a graphics view with a GL viewport and stuff like that, then for us it was just hell because we have like millions of combinations possible, and then you always have cases where Qt WebKit was underperforming, like WebGL process. Or CSS animation or stuff like that. Now that we have one supported code path which is going to be OpenGL, then we know that this one is going to, or we'll work hard to make that one work fast. That's what I said. We'll make it easier for us to support WebKit features like WebGL and so on. If we make the OpenGL mandatory, then it's over for us. We know that WebGL is going to, we can work on make it work fast because there is no other combination to support like software or other stuff. The API today, which of course is subject to change, of course, because we are still working hard on it, but we decided to split the API into two use cases, the desktop one and the touch one. Why? Because, for instance, on the Qt desktop, like we found out that, for instance, having a one view is like makes code very complicated, especially when you need to handle the touch stuff. And Qt Graphics WebView with like touch handling is a mess, especially when you're just in a case of I'm a desktop, I just use the mouse, I just don't care of, you know, managing touch events, right? So it's like in order to simplify everything, we decided to split up. And also many APIs, doesn't make sense in a touch view, right? Where you need overlinks on a touch screen, right? Like you don't have over events on a touch screen. So it's like simplifying like we have a common, like on the implementation we have like a common part basically, but like the API itself is much more simpler in the touch web view than the desktop web view, just because some feature doesn't apply on the touch world. So we decided to split up for code simplicity and for also not blowing the API on feature that doesn't make sense in some of the worlds. The API is focused on QML. So we want to have QML elements. So you will do like import Qt WebKit, and then you get a QML element up and ready for using in your app. But don't worry, C++ API is still here. I mean, the QML element is using the C++ API. We just have a plugin for it. It's just like, by API focused to QML, I meant that it's going to be an API property based, right? Because QML is just about properties, right? So of course, like you will have like a bunch of properties that, in C++ you could just have solved them with enum. But enum is not very usable in QML, or it doesn't really make sense. So for instance, we have like, the API will look nice for QML, but it will be usable in C++, but it will not be the main candidates for API decision. Like we're not going to say, for instance, we say we're going to put properties rather than enum because we want to focus for QML. So in C++, it's going to look more verbose, but it's still going to work, right? It's just that we're not going to put enum for it, as the example I was explaining. But the API is there. Symbols are exported, H files are there, documentation will be here, so you can still use it in C++. Doesn't make sense. And the QML elements, you use them. So make no mistake, there will be C++ API. Just that the API is going to look nice for QML rather than C++. So a tiny example, for instance, so you can create this desktop web view in QML. You can fill it with like the anchor, it has all the anchor property stuff like in QML, and you got a bunch of signal, slots, and so that you can connect them to QML when the loading starts, when the load succeeds, when the load fails. You got parameters with the signal, so you can get the error code and do something in your application. And for instance, you get on link over. This is for the desktop use case, right? Doesn't make sense on the touch screen, right? So this API doesn't exist on the touch web view, for instance, right? And in other part of the code, for instance, you can use it webview.load, and then you just give the URL and it starts loading for you. So very convenient to use, very, very fast. But WebKit 2 has like huge challenges. Of course, I was explaining, it's asynchronous. That makes API design really, really tough to make. And some of the APIs are very, very complicated to port, namely Qt Web Elements, evaluate JavaScript, and add to JavaScript window objects. So those are like, for those people that make hybrid applications. Why? Because those guys, they rely a lot on WebCore internal. So you remember WebCore is like all these tools that you need to render the HTML page and so on. And these APIs, they sit on the UI process, right? But the WebCore is not anymore on the same process, right? It's on the other one. So it's like, it starts to be really, really bad. And so they rely on WebCore internal, so of course it's on the other process, which means that you cannot use them directly, so it has to go through IPC. And then evaluate JavaScript is like synchronous, right? It's like you call something and then you get a return value. It's like we can have synchronous calls from the UI process, right? It's going to block the web process while doing stuff. It's just wrong, right? We don't want synchronous API. Now, of course, we have to solve it. We know that, hybrid applications and hybrid features of Qt WebKit is one of the strong points of WebKit. So now we're still looking at how we could solve those hybrid use cases. And we don't have yet the big picture, but we're going to change the way your application is talking to WebKit. like Q web element, the way it exists today, is not going to be the same way for WebKit 2 just because it's asynchronous. And it may not, it's like WebKit 2 is a huge work for us. It's like, it may not be yet ready that in 5.0 you have like already a one-to-one mapping for hybrid functionalities. But they will come with like 5.1 or 5.2, right? It's like 5.0 is not the last version of Qt 5, right? So it's like, we're still working on it. But basically, it will change the way you talk. It's like, it's going to be more like JS Worker, if you know what it is. Like JS Worker is like when you thread, like you can make JavaScript execution on separate threads, right? So it's like you can say, okay, this piece of code of JavaScript is very heavy. I'm going to just throw it on a separate thread. This is HTML5 feature, right? And then how this API works is like, is messages and callback, right? You communicate to this thread by messages, and then you get callbacks when, for instance, the thread is down. And I think it's going to be the same way. You're going to say, okay, I'd like to send this message with this JavaScript code, and then it's going to go to the web process, and then when the web process finishes with it, then you're going to get a callback. So it's going to be, rather than being a synchronous method like evaluate.js, it's going to be like, I send this, and you get a callback. And for instance, there was like a lot of hybrid use cases that have like, custom network access manager. Of course, as I said, the API managed for you the web process, right? You don't know that it exists. Like you just call WebKit APIs, and then it creates the web process for you, make the communication in between. So, but the actual network access manager sits on the other process, right? And many applications, they have their own network access manager, and there was one of the strengths of the hybrid use case. Same, we have to make that possible. How? I see two options. Either we make a plugin on the web process side so that when the web process is created, it will look for a plugin that contains a network access manager that you can specify. Or we make the web process like a tiny library so that you create the web process, like so that we know that, and then you create the web process. So like the main function is you that you create, so you create the web process with a tiny API, and then you attach your network manager on it, and then we use that one for creating the web process. There's also, in WebKit 1, you could call render, and then you could render a part of the web page, and then put that into a pix map, or show it somewhere. That was a good use case of the hybrid, like you want to make an app, and then you show a piece of the website in your app, or any website. Same, how the UI process doesn't know anything about the web process, right? Like, except talking to it. So how you can, like, how we could ask you to render synchronously and then get that to a pix map is going to be very complicated. So, same. I think we are going to have a dedicated elements or class for doing that, right? So, for instance, a dedicated, like, I don't know, web slice element, QML element, where you specify the web view you're using, and then you specify a selector, like a jQuery selector. You say, oh, I'd like this element ID, I don't know, foobar, and then it's going to render only that one for you. But it's not going to be like you call render and so on. It's like it's going to be dedicated APIs for it, because we just can't do those anymore. It was just process splitting. I just have a little demo. So by the way, so I think it's fine. I'm gonna hold it. So this little demo. By the way, so this presentation was like HTML5 based, and it's running on a web browser that is made in QML2, so running in Qt 5, and this presentation was rendered using WebKit 2. So as you can see here, there's a web browser. So you have full screen mode, you can leave the full screen mode, and then you can open a new tab, and then you can go to a heavy images website. I'm not on the network. That's where I'm. Hopefully it's gonna work. Well, there's no network, so let's see. Ah, Jesus. well, I have no network, but anyway, so as like those, as fortunately I cannot show you, but it's a bit bad. But yeah, so it's like it's a web browser, like basic bookmark support. So you see, you can start doing stuff with the API we're developing, and so you can of course reload the presentation like this, and then so of course I'm gonna go to the end, and you can move the tabs around. So whoops. So a bit like Chrome basically. So up and. So yeah, it's like the cool part of it is like if you go to this, for instance, up, and then you do ps aux, and then you grep for Qt. You see that there is this Qt web. I'm gonna increase the font. How you increase it? Controls. With one hand, it's gonna be tough. Yes. So as you can see, there's this Qt web process running, as well as if I grep for my application, which is called Snowshoe. It's an open source project, by the way. So you see there is my UI, Snowshoe, and then there's this web process that is the web process I was talking about. Now, here it is the web process running, and then let's say I emulate a crash. So I'm gonna kill the web process, right? So let's say I was using a Flash plugin, and it crashes. So I kill, boom. My UI is still here, right? The web process crashed, but my UI is still here. And I just do a reload, and it's gonna reload it, right? So that's cool, right? So whatever happened on the web process, it doesn't bring down your UI, you just reload it, and then you're good to go. So makes more robust application. So of course, we want your feedback, especially for the hybrid use case, as we are discussing the APIs on the mailing list and discussing, different approaches we can have. We already have quite a lot of feedback from Richard Moore, which is not here. It's too bad. And so of course, we'd like you to, participate with us and try the new APIs and say that tells us if we can solve your hybrid use case or not. And we are usually on IRC, either WebKit or Qt WebKit. Otherwise, you can find on list.webkit.org, there is the Qt mailing list, and you can register to it and, tells us about your hybrid use case that may not work with WebKit too. But keep in mind that we're still working on, the basic functionality right now. So it's like, we may not have all the hybrid features back for 4.0. They will come at some point. We know that it's a very important use case of Qt WebKit. But we just want the stuff up and running first, like, just rendering web pages. So that's all. Thank you for your attention. If you have any question, go for it. I have to wait the microphone.
Are there any questions?
Here.
Oh, okay.
Yes, thank you. Will WebKit 1 be discontinued at some point in the future?
Like, it's just like Qt widgets. It's going to ship with for 5.0. As I was explaining, it's a separate API. It's going to be there in 5.0. We're just not going to work anymore on it, at least the Nokia employees. It works, right? It's tested. We have bots running with it every day, so if we break something, we are going to know about it, so it's not going to get worse. But it's not going to receive any new improvement, at least from Nokia, because we don't think it's the future. We think we should focus on that one and get the hybrid use case back in shape, get everything up and running, and then so that people can switch to that one. Because we think it's better. You see, right? Like, that's good.
Hi, thanks for the presentation. I was wondering about the low-level details of the implementation. I mean, especially when we're talking about Q platform abstraction, QPA. How is this surface is going to be rendered? I mean, the QPA offers the acceleration, but then you have to map this area on the same memory, like a map?
Well, so how I can explain it easy. it's like, we just draw it. It's like, see it as a Qt map, right? So it doesn't matter which platform we're running, we just draw that surface, right? It's like if you call QPainter draw a Pixmap.
So we're not going to have we're only going to have the raster painter, right?
No, it's going to be, it's like, as I said, we use SingleGraph, it's going to be OpenGL.
Okay.
We'll render this surface using OpenGL. And also, for instance, if in the future, it's like going to be all CSS animation, stuff like that, is going to be OpenGL accelerated.
I think he was asking about the web process that's raster.
Right? The process is raster, right? It's like the web process render with raster today, right? It's like today is still using QStyle, QPainter, and friends because we haven't yet get other alternative. But yeah, to actually render in the surface itself, it's raster, the web process. But then to draw it on the UI is using SingleGraph and OpenGL.
I would like to know if you have multiple instances of Qt WebKit too. Is there then only one process in background? Or?
So today, the implementation has one web process. So if you have multiple pages, like in the web browser I was running, so like here, I have one web process for those for the 3 tabs. Just because WebKit today, but it's almost there, doesn't support multiple web processes, one per page basically. But it's on the pipe. What that means is like when you create your web view with your web page, it's going to load one process dedicated for each one, right? Today is not the case.
Is it possible to make a decision in what you use?
Probably making a decision. You'll be able to decide.
Okay. Thank you.
So I'm wondering if it's is it correct that there's only one WebKit web engine, and that's shared between, call it WebKit 1 and WebKit 2?
Yes.
And so does that mean that as WebKit development continues with like HTML 5.1 or whatever, that those will sort of implicitly come also to the WebKit 1 bindings?
Exactly. I mean it's like you have to see that the WebKit layer, or like the Qt WebKit layer, is tiny. It's not that much code. We use the web core, and the development of HTML features happen in web core. So even though we are not going to work on Qt WebKit 1, or at least no employee are not going to do it, I think, we are not going to improve the API, right? We're not going to add API, but the features in the engine itself, you'll get them for free. I mean, if we support, I don't know, new input type in HTML, those will work for free on the WebKit 1 API, right? Because there's no, it's like they use web core, right? So it's like those will work. So WebKit 1 will still evolve as web core is continuing evolving. What I think we should not focus on is adding more APIs in Qt WebView and Qt Desktop WebView and so on. But having improvement from the engine, you will get them for free, for sure. Then thank you for assisting, and I hope you'll enjoy the conference.